Hello students! In class we looked at trigonometric functions, all 6 of them, and we defined them in terms of the unit circle. And so in this video, I just want to quickly recap what we talked about in class today. There are 6 trigonometric functions that you will deal with both in this Foundations course and Calculus 1. Those are sine, cosine, tangent, cotangent, secant, and cosecant. We first talk about the cosine, the sine. So these are defined based on, and in class we introduced and talked about our idea of SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, because everybody seemed to remember this from high school, or those that had taken some kind of trig in high school had remembered this little acronym, and so we went with it. So we said that sine of a function is always the opposite side of that angle. So if I have an angle theta, then sine would be the opposite over the hypotenuse, and we mentioned this in class. The cosine is the adjacent over hypotenuse. Cosine, adjacent, hypotenuse. And the tangent is opposite over adjacent. And what does that mean in terms of a right triangle? Well, if you have an angle theta, if you look at, first of all, the side that's across from the right angle, that's called our hypotenuse. And then the side that touches the angle in the right triangle is said to be the adjacent side because it's touching the angle. And then the side directly opposite that angle is called your opposite side. And so we talked both when we introduced right triangle trig, and then when we talked in class today, we said that we can use the acronym SOHCAHTOA to help us find all the values. Sine would be a ratio of the opposite side divided by the hypotenuse, cosine the adjacent side over hypotenuse, and tangent the opposite side over the adjacent side. And it's all in reference to your angle theta. Now remember, cosine, sine, and tangent are ratios of numbers. Now how does that play out on the unit circle? If we come down over here on our unit circle, and we have a point here, xy, and this lies on the circle, x squared plus y squared equals 1, right? And I drop down a perpendicular to the x-axis. What I create right here is a right triangle. Now, for our picture, that right triangle has an angle T, where the initial side is the one lying on the x-axis and the terminal side is the one that goes actually to that point, xy, right here. So, because I'm on the unit circle, my radius is 1. And that means the hypotenuse of that right triangle is 1. Similarly, if I look at my point, x comma y, my y distance is the one that runs up and down vertically, and so my y is represented by this tall side right here for this picture, and my x runs along the x-axis, and that's this distance right here in the right triangle. So I see 3 sides in this right triangle. I see my right angle, and I see my angle itself. So referring back to our SOHCAHTOA idea, we can first start with sine. Sine is the opposite over the hypotenuse. And so if I want to say what is the sine of angle T, I can look at my opposite side, which is y, divided by my hypotenuse, which is 1. And so sine of T is just y on the unit circle. In a similar fashion, we can also calculate cosine. Cosine is adjacent over hypotenuse, and so if I look at my angle and I look at my adjacent side, I see that the cosine of t is the x side, the length of x, divided by 1, which is the hypotenuse, and that's just x. And so this creates some fundamental definitions that you want to remember. On a unit circle, your x value is just your cosine, for the angle. And your y value is just the sine for the angle. So the y value is just the sine of the angle. And so every point on the unit circle has cosine being the x-coordinate and sine being the y. So in class, we warmed up by taking out and looking at our unit circles. And let's just do these two warm-up problems. So if we look at the point on the unit circle that corresponds to the angle theta being 120 degrees, I know that my 120 starts at the standard position and rotates 120 degrees and terminates, because it's in the positive direction. And the point on the unit circle that corresponds to 120 degrees on that circle of radius 1 happens to be the point -1/2 square root 3 over 2. And the second warm-up problem, let's determine the following values. Sine of 5 pi over 6, cosine of -pi over 4. And again, we did these in class, something like this in class, so I'll go quickly over them. We're just quickly reviewing and refreshing everything we did. You can always pause the video, okay? But what do we do to get the sine of 5 pi over 6? Remember, sine, according to our definition, is just the y value, right? So we're looking for the y value, that's our y value, at the angle theta equals 5 pi over 6. And so first of all, we have to find that angle 5 pi over 6. It's positive, so we know it's going to be traveling counterclockwise. It starts here and goes 5 pi over 6, which is almost all the way to pi. Almost 6 pi over 6, but not quite. It's 5/6 of the way, right? So that's my angle, 5 pi over 6. And on the unit circle, there is a point that hits that angle, and that point right there happens to be negative square root 3 over 2, 1/2. So the point that intersects the unit circle with the angle 5 pi over 6 is negative square root 3 over 2, 1/2. And in previous videos, we talked about how to get that. And so if I want to get the sine of 5 pi over 6, I just want to get the y value. And so that ratio is 1/2. So we would say that the sine of 5 pi over 6 is 1/2. And finally, together, we will do cosine of -pi over 4. Again, our very first thing that we have to do is draw the angle -pi over 4. This time, when I start in standard position, because it's a negative angle, I have to move in the clockwise direction, so that's the negative. And pi over 4, we know, is 1/4 of the way to pi, or 45 degrees. So that's the angle -pi over 4. Now again, that hits the unit circle in a point. And that point is, remember, it's where the x's and y's meet each other. They're the same value. They satisfy x squared plus y squared is 1. And that point right there is square root 2 over 2, negative square root 2 over 2, right? Because I'm down here in the 4th quadrant. This time I'm looking for the cosine. And remember, cosine is our x value. And so we are looking for our x value when theta is -pi over 4. And that x value should be a ratio, right? Ratio of two sides. And that actually is a ratio. So if you check it out, it gives you square root 2 over 2. And that is the cosine of that angle, -pi over 4. All right, I'm going to leave you with one to practice. Oh, wait, I'm jumping ahead of the game here. We just did sine and cosine. One more thing we have to quick review, which is all the other trig functions. You're like, Tina, wait, what about tangent and cotangent and secant and cosecant? Oh yeah, we can't forget about them. So let's talk about them. Alrighty, tangent, cotangent, secant, cosecant. How do they relate? Well, again, we can go back to our triangle if we want to talk about it. We mentioned this in class, right? We have a right triangle. And tangent, so if we go back to our whole regenerating what knowledge we have, we said tangent. So if we have the tangent, and in this case I have an angle T, right? So the tangent of any specific angle will always be the opposite side divided by the adjacent side in a right triangle. Opposite over adjacent. And looking on our triangle, remember the length on the bottom of that right triangle is x. The length up the side is y. And so if I want to look in reference to that angle right here, T, I want to take the tangent of T. I'm going to look at my opposite side, which is y, divided by my adjacent side, which is x. And the coolest thing in the entire world, right, is that notice when you're on the unit circle, what did we say y was? Y is just the sine of T. And x is just the cosine of T. And so for anyone that might have taken trig before, this should also look very familiar. It is the basic definition of tangent. Tangent is sine over cosine. And we talked about it in class very quickly today too. So tangent, and I have all four basic trig functions here that go with sine and cosine. Tangent is the quotient of sine divided by cosine, or y over x. Cotangent is the reciprocal of tangent, right? They're reciprocals of each other. And I'll highlight that by writing right here, they're reciprocals of each other. Reciprocals means they're multiplicative inverses. And so to get cotangent, you just have to take 1 over tangent. Or if tangent is y over x, we reciprocate it and get x over y, cosine over sine. So cotangent is cosine over sine. Secant is the reciprocal of cosine, which is going to be 1 over x. And cosecant is the reciprocal of sine, which is 1 over y. And so now I'm ready to leave you with a problem for you to practice. We did a couple practice problems in class. This is our third practice problem. Evaluate all 6 trigonometric functions for theta equals negative 3 pi. Theta equals negative 3 pi. Now I throw you for a loop here because number 1, it's a negative angle. Number 2, you go all the way around the circle and a little more. But that's okay. And then number 3, some of these might be undefined. So I want you to think about that. So your task is to find the sine of negative 3 pi, the cosine of negative 3 pi, the tangent of negative 3 pi, and the other 3 trig functions, which are our reciprocal trig functions. The reciprocal of sine is cosecant of negative 3 pi. Reciprocal of cosine is going to be the secant of negative 3 pi. And the reciprocal of tangent is the cotangent of negative 3 pi. And remember, when we take a trigonometric function, what we're looking for is a ratio. We take a trigonometric function of an angle and we get a ratio back. So try those and then I'll throw you up the answers so you can check. So take a moment, pause the video, try those. Okay, and let's see if we match answers. Very first thing is you want to locate where that point is, or excuse me, where that angle is, negative 3 pi. So we start in standard position and we rotate in the negative direction, which means we're going to go clockwise. Negative 2 pi, right? I want to go at least negative 2 pi, and then to get negative 3 pi, I have to go another pi. So that angle right there is negative 3 pi. Now the unit circle will intersect that angle, which is an interesting angle. It's on the x-axis right here. And what is my point? My point is negative 1, 0. And therefore, let's find all the values. Remembering, sine is y, cosine is x, tangent is y over x, cotangent is x over y, secant is 1 over x, cosecant is 1 over y. See if you're matching my answers. I have that the sine is 0. I have that the cosine is negative 1. I have that the tangent is 0 divided by negative 1, which is just 0. I have that the cotangent is negative 1 divided by 0. Can't have 0 on the bottom. That means cotangent is undefined at negative 3 pi. Secant is 1 divided by x. That's just negative 1. And cosecant is 1 divided by 0. Again, can't have 0 in the denominator. We cannot divide by 0. Everything blows up. And so we would say that the cosecant is undefined. Great work. Okay, so in the next quick review video, I will review inverse trig functions, but that's all for basic trig function review for now. Have a great day and good luck with your study.